Hey developers, welcome back to my channel. I'm excited to bring you the 5th installment of our Dart series. As I promised, we will be covering new topics in each video to help you become a master of the language. In our previous video, we just explored Dart collections, spread operators, and enums. Now, we are going to dive into a fundamental concept of programming, which is OOP, Object-Oriented Programming. So in this video, we will start with the basics, what is OOP and why it's such an important concept to understand, and we will also cover 4 principles of OOP, also what are the benefits of using OOP in your code, and go over how they are used in Dart. So by the end of the video, you will have a solid foundation in OOP principles and be able to apply them into your own Dart projects. So sit back, grab a cup of tea or coffee, and let's dive into object-oriented programming in Dart. What is OOP? OOP stands for Object-Oriented Programming. It's a programming paradigm that focuses on using objects to organize and structure code. In OOP, everything is treated as an object that consists of 2 parts, data and behaviors like methods and functions. 4 main principles: encapsulation, the act of hiding private information or private things; abstraction, the act of simplifying complex systems by breaking them down into smaller, more manageable parts; inheritance, the ability to create new classes based on existing ones, inheriting their behaviors or attributes; polymorphism, the ability to use single interface to represent different types of data. Now, there are 3 types of OOP: class-based, object-based, and prototype-based. Objects are created from classes and objects are created from templates. Also, objects are created from existing objects. New objects inherit properties and methods from the existing objects. Let's have a look at benefits. Modularity enables programmer to divide complex problem into smaller and more manageable pieces, making it easier to design, develop, test, and maintain software. Reusability emphasizes code reusability, developers to use code for multiple applications without the need of rewriting. Encapsulation, as I said earlier, which means the objects can be hidden from other parts of the program. Inheritance, create new classes based on existing classes, reducing code duplication and improving efficiency. Polymorphism, create objects that can take one different form, making code more flexible and adaptable. Now, let's take a look at a simple and basic example of class, object, and constructor. Let's take a simple basic example of classes, objects, constructor. I have a person class in which I have defined a method introduce which will print, "Hi, my name is Queen." Now, we usually call a function like this, but this will give me error because introduce method is defined inside of a person class. I cannot access outside of that class, right? So how I call this? I should call this function or access this function with the help of object, where obj is the object name and person is the class. This is my person class object. Now, with the help of this, I can access this introduce function, obj.introduce. If I run this, you can see, "Hi, my name is Queen." Now, this is the example of object and class. Now, take a look at constructor. I have defined 2 variables, string name, int age, and there is a constructor person, this.name, this.age. And function as it is, just let me replace name with the name variable and age. This is called the string interpolation, right? Now, if I look at a main, it will give me error in my object. Why? Because I need to define the name and age. Why we use constructor? Define a constructor that initializes these properties when a new person object is created, or your class object is created, right? That's why we define that constructor. Now you can see I have created one object, one person object, Queen, and another person, Ali. I can create as many objects as I want with the one class. Okay? I can create many persons with my person class. Now let's take another example of a class car. I have defined 3 variables: make, model, int, air, and there's a constructor for initialization. Now there are 2 methods, start and stop. Also, I have defined the make and model name inside of my start or stop function. Now what I do, I'll create a object car1 Honda Civic. Now you can see I have created 2 cars with the help of one class, which carries both the properties and data. This is the benefit of class, object, and constructor. We could make as many objects as we want. We don't need to write specific or individual codes again and again. Let's take a look at encapsulation in Dart. As we know, encapsulation is hiding data or hiding information from other parts of your program, right? I have defined a class person which has 2 private variables, name and age, and the constructor. In addition, I also defined the getter methods. Now, what is getter method? Getter methods for the name and age variables which allow other parts of the program to access their values without being able to modify them directly. These 2 are private, right? So I cannot access their values. So that's why I should define the getter method to access their values without being able to modify them directly, okay? I also defined a private function which is incrementing my private age variable. Also defined another normal function, celebrate birthday, which is calling my private birthday function and print call. Now, when I create person's object with the value L is 30, I should call like this person.celebrateBirthday and run. But I cannot call person._birthday method which is private. This is called the encapsulation. I can access all the data, all the behaviors, all the methods of that class with the help of object, but I cannot access private information inside of that class. Like private variables, I can access their values with the help of getter and private function. I cannot call private function outside of with the help of object. This is called encapsulation in Dart. Abstraction is the process of hiding complex implementation details, exposing only the essential features of an object. In Dart, abstraction is achieved by using abstract class and methods. I have created abstract class shape which defines abstract method getArea. Now, another class rectangle which implements that shape class, and I'm overriding this getArea method, returning width and height multiplication result. Now, when I create object of that rectangle with the value of 10 and 20, and I should call like this, this is the correct code. But if I create object of a shape class, this will give me error. Why? Because abstract class cannot be instantiated and it is used as a blueprint of the other classes to implement its methods. Okay? Inheritance, the concept of creating new classes from existing ones, inheriting their properties, methods, data, and functions. In Dart, inheritance is achieved by using keyword, extend keyword, to create subclass that inherits from a superclass. Animal class having private variable, constructor, and a method eat. Dog class inherits animal class and there is a constructor. Now, what is this super name? Dog is a subclass of animal, and by calling super in the dog constructor, we are passing the name parameter to the constructor of animal class. This is the example of using super keyword to call the constructor of a superclass from a subclass. I hope you understand that. Now, when I create dog object, I can access eat method as well as bark method. Dog can inherit all the animal class behaviors, methods, and data. Let's create another class cat which inherits animal class and their properties. create object cat.eat and cat.meow. What if I want cat could inherit dog class as well and their properties and data information? In that case, cat class extends the dog class, which in return extends the animal class. As we know, dog is a subclass of animal, right? So cat is a subclass of dog now. And the cat constructor calls the super constructor with the name parameter to pass it up the chain to animal class. And the cat class has a meow method, eat and bark now, because bark method inherited from dog and animal respectively. Polymorphism is the ability of objects of different classes to be treated as if they were objects of the same class. In Dart, polymorphism is achieved by using the interface and abstract classes. We have an abstract class animal that defines a make_sound method. We also create two classes dog and cat that implements animal class and overriding make_sound methods to produce their respective sounds. Now, in the main function, just created the objects of dog and cat and stored them as an animal object. Why? Because we cannot create abstract class object. That's why I just defined the animal object type. Then we call a make_sound method on each object which produce the appropriate sound for each animal. So this is the example of polymorphism, because even though dog and cat are different types, they can both be treated as animal object and their sounds method can be called in the same way because we just override it. This allows us to write more flexible and reusable code that can work with a variety of objects that share a common interface or superclass. Now, let's take an example of 4 principles in one code. Encapsulation, abstraction, inheritance, polymorphism all together in Dart. So first, there is an abstraction, abstract class animal with the private variable which represent encapsulation, constructor and the getter method, and there is a make_sound method. Okay. A cat class extends animal class which represent the inheritance, and there is a super constructor call. Also, I'm overriding make_sound which represent the polymorphism. And there is another class dog which extends animal, the inheritance, and I'm overriding make_sound method polymorphism. Now I'm creating the objects cat and dog and then calling the method respectively. 4 principles are all together. Thanks for tuning into today's video, developers. I hope you have learned about object-oriented programming in Dart. Remember, understanding OOP principle is crucial to writing efficient or clean code. So be sure to practice and apply what you have learned. As I always committed to bringing you the latest and greatest in Dart programming, right? So be sure to stay tuned and the next of our series, which will be the last, because only asynchronous programming and error handling is left. More advanced topics of Dart we will be covered in our Flutter videos. So if you enjoyed this video, please don't forget to like, subscribe and share it with your fellows. I'll see you in the next video. Thanks for watching.